Hello friends, welcome to my channel. We are going to solve a problem based on division lemma and remainder theorem. So we have given a problem which is based on division lemma and remainder theorem. So first of all we state the division lemma and we state the remainder theorem and we use these theorems in solving above problems. So what is the division lemma is? So first of all, division lemma. We have division lemma for polynomials. For polynomials. Let fx and gx be two polynomials in Rx. What is R? R is a field of real number. R is a field of real numbers. Again, what is meant by Rx? That is the coefficients of polynomial are real numbers. This means the coefficients of polynomials are real numbers. Coefficients of terms in polynomial are real numbers. So, and we have given that and gx is non-zero, then there exists unique polynomials qx and rx in this set of polynomials such that fx equals to gx into qx plus rx, where either degree of Rx is less than degree of Gx, or Rx is the zero polynomial. If Rx equals to 0, then we say that polynomial gx divides fx, or fx is divisible by gx. Again, we are moving on remainder theorem. Note that in the division lemma, Rx is remainder. Rx is remainder when fx is divided by gx. Again, we state remainder theorem. What is remainder theorem? We have given a polynomial fx, and when fx is divided by a linear polynomial x minus a, then remainder is f of a. So the statement of when a polynomial fx is divided by x minus a, then remainder is f of a. So we are going to use these theorems in solving above stated problem. So we have problem is, if a polynomial px is divided by x minus 1, then remainder is 2, and when fx is divided by x minus 2, the remainder is 3. What is the remainder when px is divided by x minus 1, x minus 2? So first of all, we use the first statement. What is the first statement? Is when px is divided by x minus 1, the remainder is 2. So by remainder theorem, p of 1 equals to 2. Why? Since if we divide p of x with x minus 1, the remainder is 2, and when px is divided by x minus 2, the remainder is 3. So by remainder theorem, p of 2 equals to 3. Again, we have given a polynomial px, and we have to divide by this px by gx, which is a quadratic polynomial, x minus 1, x minus 2. So our remainder rx must be less than the degree of gx. So remainder, so by division lemma, px equals to qx x minus 1 x minus 2 plus rx. And what is rx? Rx must be less than degree of rx must be less than degree of gx, and this equals to x minus 1, x minus 2. That is, this is a quadratic polynomial, so this must be, rx must be a linear polynomial. So let's suppose rx equals to ax plus b, for some a and b are in real numbers. So again we use this, so we can write it as follow. So what would be p of x can be written as q of x, x minus 1, x minus 2 plus ax plus b. Again, p of 1 equals to, we have given p of 1 equals to 2. This implies that this term becomes q of 1, 1 minus 1 and 1 minus 2, and this becomes a plus b equals to 2. So this term goes to 0, this term goes to be 0, so this is 0, and this a plus b equals to 2. So we have equation number 1. Again we have given that p2 equals to 3. So in similar way, this term goes to 0, and this becomes 2a plus b equals to 3. So this is equation number 2. By solving equation 1 and 2, by 1 and 2, we get, by solving these are the linear equation in a and b, so we solve it by elimination method. So eliminate b and we get a. So what is the value of a? A is minus a equals to minus 1, so a equals to 1 and b equals to 1. So what is the remainder? the remainder is the remainder is Rx equals to Ax plus B, and we have found that A equals to 1 and B equals to 1, so a remainder Rx equals to x plus 1. So this is the answer. So thus we have solved